In this video, I'm going to do analysis of writing and balancing chemical equations. And as I said earlier in my last video, we are going to use the periodic table that we did initially to help us write and balance chemical equations. Now, mostly to understand writing and balancing chemical equations, students need to know certain things that are very important. Now, before I dig deep into writing and balancing chemical equations, there are things that I have to explain first to enable you understand whatever thing that we are going to do. Periodic table of element is a funny table in a way because sometimes it contradicts what is displayed. Certain elements in the periodic table have symbols that are neither the first or the second letters of their English names. So there are certain things that I still want you to understand as a student, that from the periodic table, an element such as sodium potassium, mercury, silver, these elements and other elements that you'll meet, you'll come to realize that, for example, let me add another element, lead, which some people call lead. I don't know, but I know it's read as lead. If from the periodic table, it could have been better if their symbols could have been the first and second letter of their English names. But if you check the periodic table very well, you realize that sodium is not SO or even S. Potassium is not P or even PO. Mercury is not even M or ME. Silver is not even S or SI. Lead is not even L or LE. But instead, they have unique type of symbols. Now, as a student who is starting to learn chemistry and trying to understand the periodic table, I know you are wondering and asking yourself, how did these people come with these names? And I want to help you understand that. Now, these names or those symbols that you see there, certain elements in the periodic table have symbols that were driven from first or second letters of their Latin names. So that's something that I want you to understand as students. They have symbols that are not driven from their English names, but the symbols that they have were driven from the first letters of their Latin names. So now, let us dig deep and see. Sodium has a symbol Na, and this Na was driven from the Latin name of sodium, which is natrium. Potassium has a symbol capital K, and its symbol was driven from the Latin name of potassium, which is kalium. Mercury has a symbol Hg, And these symbols were driven from the Latin name. Sorry, I did not indicate here. These are Latin names. All these ones are English names. So this one is hydrogeram, hydrogeram. Silver, silver is Ag, and the symbol was driven from the Latin name of silver, which is argentum. Argentum. Lead is Pb or lead, Pb, and the symbol was driven from lead's Latin name, which is plumbum. Some people call it plumb. I don't care how you're going to call it, so long as you know where you know the Latin name, and also it is from that Latin name where we draw all these symbols were driven. So if you find that contradiction in your periodic table, I've explained it here, and it will enable you understand certain symbols that are written in chemical reactions. Now, that's what I wanted to explain. Now we can dig deep now into writing and balancing chemical equations. Now, in writing and balancing chemical equations, it is as simple as we explained initially. To write and balance a chemical equation, as a student, there are things that you need to know. The first thing is which elements are reacting. Which elements are they? The elements that are reacting you need to know very well. You really need to know them, and from knowing them, you'll be able to understand whatever thing that is happening in that given chemical reaction. For example, if an element that is reacting is a metal and a non-metal, we said initially that metals react by losing electrons and non-metals react by gaining electrons. So it is that principle that governs our chemical reaction, because each and every element want to attain stability. So at the end of the day, the compound that is going to be formed must be a stable compound whose outermost energy levels are full or is full. Now let me start with a simple reaction. I can react a metal and a non-metal. Then at the end of the day, I'll form my product. So I can decide that my metal is going to be any element from the periodic table that has electronic configuration ending with 1, 2, or 3, and any non-metal that has electronic configuration ending with 5, 6, and 7. As simple as that. So my work is just to go and look for those elements in the periodic table. Now, if I decide that I'm going to react any metal, for example, I can take metals in the group 1. I can take lithium. So I'll have lithium. Then I react with any non-metal, which is oxygen. Then when I react a metal and oxygen, I'm going to form an oxide of that given metal. So it is going to be lithium oxide. It is going to be lithium oxide. Now this thing that I've displayed there is called word equation. It is from the word equation that you can derive a chemical equation. that you can study in depth. Now, after writing word equation, I'm going to introduce the symbols. So, the symbol for lithium from the periodic table that we analyzed initially was Li, and since it is a metal, I'm supposed to write the state symbol. This is a solid. I'm going to react it with the oxygen, and oxygen is a gas. Most gases are diatomic. Let me explain that also in depth. Most gases are diatomic. I know someone is asking, Timura has said that what is the word diatomic? It's simple. Diatomic means they exist in pair. Meaning, if I'm having oxygen, I must have O2. If I'm having nitrogen, it is N2. If I'm having hydrogen, it is H2. If I'm having, think of any other. Now, the next thing that I also wanted to understand is that most stroke almost all group 7 elements are diatomic. So, through the analysis of predictable, you'll understand that group 7 elements are elements which have 7 electrons in their atomos shell, and there I'm having fluorine, chlorine, bromine, iodine. Now, in real sense, now if I'm writing them, it's supposed to be F2, Cl2, Br2 because they are diatomic, and lastly I'm going to have iodine 2. Now you needed to understand that before you further your studies in writing and balancing chemical reactions. Now, having known that gases are diatomic, now I can analyze and understand how these elements can react to yield a certain products that I'm interested in. Now, so here I'm going to put oxygen, and the oxygen is going to be O2. Then I'm supposed to form this. Then now, since we are beginning to understand chemistry in details, and I'm assuming that we've not gotten the opportunity to learn chemistry in depth, I'm assuming that you still don't know the product and how it is supposed to be written. If you visit my previous video, which I was analyzing the periodic table, I talked about something called valency. And in here, I'm going to add something that I did not I did not talk about there in my last video. Any metal that reacts by losing electron is given a positive charge sign. And any nonmetal that reacts by gaining electrons is assigned a negative charge in the formation of their ions. That's very key. So, after getting that knowledge, now let us see how that knowledge is going to help us now write and balance chemical equations. Now, Lithium, Li, has atomic number 3 and electronic configuration of 2:1. Oxygen, O, is atomic number 8 and has electronic configuration of 2:6. Now, in terms of their ion formation, I'm going to have lithium. Lithium cannot gain 7, and oxygen cannot lose 6 because it is a nonmetal, but it would rather gain 2 to become stable, to obtain a 2:8 rule. And lithium cannot gain 7, but it will tend to lose 1 to achieve duplet rule. Duplet means double, to achieve a 2 electronic configuration in its outermost shell. Because when this one goes, now it is only this that will be remaining. But when now 2 electrons are added here, at the end of the day, we'll be having this configuration. It is very key that you understand that. I will do several examples and you'll be able to understand everything that is going on at each and every stage. Now, let me come back to whatever thing I was explaining so that we see how this chemical equation can be completed and balanced. Now, I said this one had 2:1 and this one is 2:6. Now, in the formation of their ion formation, what am I going to have? I'm going to have lithium losing 1 electron. And since 1 is the same as the charge, I'm going just to put positive 1 on top of it. And this is a small letter. Plus, oxygen needs 2. It needs a 2 to become 2:8. So it is going to be a 2 minus. So when this happens, this is where now I'm bringing the concept of interchanging the charges. If I interchange their charges, the positive 1 is going to come this side and the minus 2 is going to come this side. So at the end of the day, I'm going to form a compound because the two are uniting. I'm going to have lithium 2 giving me this product. So it is this product that is going to be formed whenever lithium and oxygen react. So this is the product that we are supposed to go back to our chemical equation and fill in. And when that happens now, what am I going to do? I'm going to simply remove this line now, because now we've understood what we are dealing with. So I'm going to put Li2O as my product. Then I'll simply come and remove all this because it is not now necessary. It was just knowledge that we needed to make us understand whatever thing that we were doing. It was just to enable us understand what was happening in that reaction. And now we've understood. Now, this is my chemical equation and the product. I have my gas, and since when metals react with non-metals, most of the time we form solids. So they are still solid. And these are just state symbols. Now, I've written it. Now I need to balance it. How do I balance a chemical equation? To balance chemical equation, you really need to ensure that each and every element on the reactant side, this side, before the arrow, is called reactant side. Reactants side. And this one is product side. Product side. Now, what am I going to do? The key thing that you need to know, to balance a chemical equation, you have to ensure that one, all atoms of each element are equal in number, on both sides of the chemical equation. Now, if you know that, then you are simply going back to our chemical equation that we had, and we are picking each and every element. My first element is lithium. The element that I have here is just one, because I don't have any value written here. There's no value written there. So if there's no value written there, I'm simply going to assume that it is 1. So I am having lithium 1. And on this side, on the product side, I'm having 2. This 2 shows that for every oxygen to be stable, I need 2 lithium elements or atoms to donate 1 electron each, because oxygen needs 2. So if that happens, it shows that I'm supposed to be requiring 2 lithium. So if lithium is 1 on the reactant side, this side I have 2. Oxygen is 2 because we have 2 atoms of oxygen, because it is an oxygen molecule. I have 1 on the product side. How do I make them equal? That's the question. How do I make them equal? So, because my space is filled up, let me erase some part so that you can find a space to write. I really like writing a lot, because through writing we tend to grasp a lot of knowledge within a short period of time. So when you see me write a lot, it's because I want my students to understand every bit of whatever thing I'm explaining. And if there's any part that you still don't understand, you can replay the video as many times as you want to enable you understand all the concept that we are teaching. Now, I have my space, and in this space now, I'm just going to ensure that I can write somewhere. Now, I also want to remove this, and don't forget that you can write it somewhere. Most of the time when you're attending my classes, always ensure that you have a pen and a paper with you, because I tend to just quote some statements that are very key, and sometimes you may end up forgetting them. So you should be having a pen and a paper with you to enable you jot down some points. Now, here, now we want to do the balancing. If you're going to do the balancing, I have now created enough space. So how am I going to come up with a situation whereby oxygen, which is a 2 on the product side, or the reactant side, sorry, must be a 2 on the other side? So I'll introduce something. And what I'm going to introduce here is just joking with the numbers to ensure that they are equal. So if I put any value here, it will affect lithium and oxygen at the same time. So that's the point where I'm going to start with. So I must start from that point. So if I'm going to start from that point, let me assume I'm putting a 2, the least value possible, a 2. Lithiums are now 4, oxygens are 2. Let me remove these ones so that we can have proper and neat chemical equation, so that my students may not sue me for writing on a shaggy page. Now, I've placed a 2 here. Now, by placing a 2, because initially we had 1, if I place a 2, lithiums are going to be 4. Meaning, how do I make lithium 4 on this side? I'm going to put a 4 here because it was originally 1. Then through that, I've just finished my chemical reaction. It is now balanced. I have 2 oxygens on the product side, 2 oxygens on the reactor side, 4 lithiums on the product side, and 4 lithiums on the reaction side. Now, this is how we write and balance chemical equation. Now, let's take our time and write and balance this for me. Sodium, sorry, try this for me, or we can try it together. I'll give you a little time so that you try it. Now, let us have sodium, solid, reacting with chlorine, gas. What do you think is going to be formed? Give it a try. As you are doing that, I also want you to try magnesium, Mg, solid, plus bromine. In 1 minute, without wasting time, I'm assuming that you've tried it, and now let us confirm the answer together. Now, in a situation whereby now I'm having sodium reacting with chlorine, I don't know the product, and now we want to come up with the product together. I said before that the electronic configuration of sodium is 2 is to 8 is to 1. Chlorine is 2 to 8 to 7. Now, sodium will give chlorine its 1, and at the end of the day, we are going to have a situation by sodium positive on top plus chlorine with a minus, interchanging their valencies, and also at the end of the day, we are going to form NaCl. So that's what we are going to put there at the end of the day. So meaning, if I come back to my first equation, I'm going to have a situation whereby now I'm simply putting in whatever thing I've found here. So I'm having NaCl, which is written as sodium, which is known as sodium chloride, and it is a solid. Now, how do I balance it? The same concept is the same. It's still repeating itself here. I put a 2 here. When I put a 2, now chlorines are 2, and I put a 2 here. And now all my substances are balanced, both on the reactant side and also on the product side. Now, let's come back to a group 2 element reacting with a group 7. Now, magnesium is in group 2. So, the electronic configuration of magnesium is very simple. The electronic configuration of magnesium is very simple. Magnesium is number 12 with the electronic configuration of 2:8:2. Bromine is in group 7. So bromine, I'm going to have a B with a minus because it is found on group 7. So magnesium is going to be Mg 2 plus and Br minus. So when such a reaction occurs, at the end of the day, they are going to interchange their valencies. Simple as that. Then we form MgBr2 at the end of the day. So that's what I'm coming and write here in a simple way, simple and easy way. So I'm having MgBr2, which is a solid. Now I'm going to the balancing part. Supposed to balance my chemical equation in a very simple way. So if you check very well, I'm having 1 magnesium because 1 is here. This one is 2. Magnesium is still 1 here. And Br, this only represents the Br. So if you look at that, you'll come and realize that our equation is balanced for group 2 reacting with the group 7. Our equation is properly balanced. So lastly, the last example, I want to do a group 3 reacting with a group 6. Group 2 reacting with a group 6. A very good example that most examiners always tend to touch on. So any group 3, most of the time we lack aluminium. I can have a situation where I have aluminium solid reacting with oxygen to give me what? Give it a try in 1 minute. Thank you. Let us try it together now. Aluminium is number 13 in the periodic table. Aluminium is number 13 in the periodic table. And if you check very well, you realize that it is number 13. It has electronic configuration of 2:8:3. Oxygen is number 8 with the electronic configuration of 2:6. Now, if I'm forming ion, I'll have Al3 positive because it needs to release 3, and oxygen will be O2 minus. So when these two elements interchange their valencies, I'm going to have Al2O3. I'm leaving it at that stage because they are not cancelling out. Could it be that there are even numbers that can cancel out? You can just simply cancel them out. Now, this is what I'm going to form at the end of the day. So that's the product that I'm coming to write here. Now, I'm simply coming here and removing my question mark that I had placed initially to create space so that I can write very well. Now, I'm having I should use same color so that you see the difference. Sorry for that. I'm having Al2O3. So how am I going to balance it? As simple as that. I'm going to do the balancing. Now, when balancing, it is easy. I'm going to take aluminium is 1 this side, oxygen is 2. This side oxygen is 3 and aluminium is 2. So what do? I really have to look for a number that when I put it somewhere here will give me an even number or same number of elements across. So I'm going to remove this, then think of a number that I can put there. Have you thought about it? Think about it. What if I put a 2? Try a 2. If I put a 2, you're just trying. There's no specific number. You joke just around with numbers until you get a number that is giving you equal proportion all through. Now, I'll have 4 and oxygen will be 6. So if I put a 2 here, aluminium will be 4 this side. And if aluminium is 4, oxygen will be 3 times 2, which is 6. So how do I make this oxygen 6? I put a 3 here. Is it balanced? It is balanced. And that's how we do writing and balancing chemical equations. Thank you very much. We shall meet in our next video.